under the UMRT. Okay, so we must start this UMRT first. Okay, when you start, it will be running in the background like this. If it's not like this, you have to restart your computer and then run again. Okay, don't close this, just minimize it. Then you can able to select this UMRT, okay, to do your simulation. Okay, then in the runtime, you must read from target and then go and select the isolated core. Alright, when you read, if you never do simulation before, if you read, it will be like that. Okay, you have to check on the isolated core and uncheck the share core. Okay, then you activate configuration. Okay, so the confusing part is your function block, your scaling. Last time I explained before, long time when we do the scaling function. The scaling for AI. Okay, this engineering value up is the real number. Okay, this real number, if this is your weight sensor, then this output will be your weight. Depend on what? The range depend on your F max and your FB. So if your F max is 100, 1000, FB is 0, this one will vary from 0 to 1000. Okay? Then we have this sensor, N sensor in. Okay, when you simulate, this one is your analog input. You cannot connect to sensor. Last time we connect this to temperature sensor, right? Then it works. But now you are simulating, you can't simulate my one is using what? Wait, not any sensor. Okay. If you ask for license, you just type in. Okay, then you should have a login button here. Okay. I'm using F pressure. Okay, so your one is called F pressure. Okay, so there's a few components inside, you don't confuse yourself. Scaling for function, scaling for AI is a function block. Every function block needs an instant name. Instant name will tell you this function block scale what. Okay, you don't go and put n speed n1, n speed 2, n speed 3. You don't know what you are scaling. You must know what you are scaling. If you are scaling for pressure, example, then this one will be called pressure sensor. So you know this is a pressure sensor. Then what is the range of pressure sensor? Up to you to define. You say 0 to 1 million, it can be 0 to 1 million. Okay, up to you because it's your own sensor. Okay, so now example, my one is 0 to 1000 bar. So here will range from 0 to 1000. But you still need to give a GVR. This is a fake analog input, but because you are simulating, but you still need to declare your AI in the GVR. So that's why it's GVR dot. Then this N sensor is integer. So in the GVR, you must declare as integer. You remember when we declare in the AI, we put N pressure example. Okay, N pressure at input is %I, asterisk, colon will be integer. So in the GVR, either Boolean or integer, these two only, because either digital input or analog input. Analog output also integer. Analog input, digital output is Boolean. So you will only see Boolean or integer in your GVR. If you put real, then something is wrong. Cannot have real because it's not an analog sensor. Analog sensor only take in integer number. Okay? So if I declare N pressure in this is in my GVR. That's why here got GVR dot N pressure. Okay? So if you write in structured text, it will be your instant name. You press F2, it will come up. Pressure sensor. then your F min, F max value. Okay, F max value what you put? You put 1000. Up to you F min value, you put 0. Then your N sensor in. N sensor in what you put? You put what you declare in your GBL. Okay, if I declare M pressure, it will be M pressure. It will be on GBL. M pressure. Okay, you see exactly the same. M pressure. Then you have finally an engineering value up. This is the one that you need to use to compare. So when I read my pressure, I want to know what is my pressure now. If it's 200, I do something. 300, I do something. So you have to, this is a real number, so you have to declare a real data type in your program. So this one, the real data type F pressure, you declare in your auto mode. If your auto mode is using this. So you see I declare F pressure is in real. Because it will convert in real number for me. Okay, so finally your engineering value up. This is the only output in your function block. Okay, it's called F pressure. You assign F pressure to it. Okay, so in your program, how you use it? So you see I use what? I check whether my pressure is. Okay, example, I have a transition. So compare. Remember I said compare is a transition, right? You want to know whether your temperature or your pressure is at certain temperature or certain pressure. So example here, I say F pressure is more than 200, that means exceed my limit already, I go back to init. Okay, so that's your pressure. Okay, so this one, after your scaling function come out, F pressure, F temperature, F whatever sensor you use, right? Normally you use as what? As transition to compare. From which state you go to which state. Temperature 10 degree, I do something. 20 degree, I do something. 30 degree, I do something. Then that's where you put your transition like this. Okay, so you need to know. Okay? Then for output, then it's the other way around. Okay, output example now I have a motor speed. Same thing. Same thing output I need. If I have a motor speed, I need have a GVL that right to my. So I put an N speed example. So digital output is %Q asterisk. It's also integer because it's analog output. Okay. Here you also have to declare scaling for AO. AO. So this one, what is this doing? Maybe this is my motor speed, so I call it motor speed. This is a function block instant name. Okay. So same thing, you have your F max, how much your motor will go. So my motor is range from 0 to 100%. This is what you want to control. Okay. Then here will be your engineering value. This is where you put your F speed. Okay. And then after that you will write the scaled AO value. Scaled AO value will go to your, this one will go to your GBL dot N speed. Okay. So you control by setting this. If you want your motor to run at 50%, set F speed to 50. If you want your motor to run at 100%, you set F speed to 100. Okay? You don't go and control this. This is tied to your analog output. So if you really use this program in real world PLC, connect to the real analog output, your motor will run at that speed based on this. Okay, based on this. Okay, so you don't go and change this. You change this. Okay? So example, you see how I instantiate my motor? Same thing, you see the instantiation is here. I call it motor speed. scaling for AI. So I will have in my GPL, I will have a N speed as an analog output. This is integer. Then in my program, I will have a F speed to read, to write. Okay, this is to write. This is to read. Okay. This one to write. Because I want to write my speed. This is to read. Input is read, output is write. Okay? So I instantiate by pressing F2. So my motor speed is 0 to 100%. And then my control is here, S speed. Okay? It's tied to my GVL. So you definitely have a GVL one. One for AI, one for AO. Okay? Then this one. Okay, then how I control my motor speed? You see, when I start motor, I want my motor to run at 50%. So my F speed equals 50. So you'll run automatically at 50. I don't need to care. But your program must be correct. Like this. Then when you show that your F speed is 50, later when you simulate here will have some number. Then it's correct. Okay? Then your simulation is correct. If the N speed is blank, then something wrong with your program. Okay? Then after that, when I stop my motor, my F speed equals to 0. Okay? When I go back to init, I want my motor to be 0 also. Okay? So that's how you control your motor speed based on state. So in init state, it must be 0. At start motor state, I run at 50%. Stop motor state, I run at 0 because it's supposed to stop. Okay? Then after that, you go in and run. So when you do simulation, you can see that okay, when you do simulation, okay, you only can write your analog input and your digital input. You cannot control your output regardless of analog or digital output. Okay, output is controlled by your program. That's why you will not go and double click this N speed and say, oh, I want this N speed to be 100%. Okay, and then you go and write. Okay, then this is a wrong simulation. Okay, the correct simulation is what? I want my F speed to control this output. Okay, so when I run my program, it will run accordingly. Okay, so okay, so when you press start, okay, then the motor, oh, I never run the. Okay, I turn on this first. Okay, so my motor turn on. You see at 50% what happened? This one will have some output. Okay, because I never put a timer, so at the stop, so that's why it's so fast. Okay, let me put a timer. Okay, then later we will see when you toggle. Okay, so now we can see it will toggle slowly. Okay, so you see after that you will toggle the. Oh, I never reset my. Okay, so you see your auto mode. After that, stop motor. Okay, you will go back to start motor. Okay. And you will go start motor. Okay, let's start again. So when I press start, press start. Here when I press start, you will go stop motor. After that, you will start. Oh, because it's also okay. After that, timer 2 lock Q. Okay, stop motor. We'll go to start motor again. That's the problem when you do last minute. Okay. Number 2. Okay. Lock Q. Why is it not true? Okay. 2 seconds. True. After that, start motor is false. Start for the last second again. You see, it jump to the. What's the problem? If timer lock Q, go to the false. Counter also never turn. Oh, okay. So when I okay, just last week I told you before, right? When you start, right, you have to make sure all your stop and your EMO are turned on first because they are negative logic. Okay, so you turn them on first before you start your simulation. Okay, so now then you can start. Okay, you say, okay, now to start my simulation, I will press my V select to run in auto mode. Okay, so now it's true, so it's running in auto mode. Okay, so when you are going in here, your V stop, VEMO, all this NC button must be on first. Okay, this is what you when you start up, right, in your PLC, this all are true also. Okay, so now I press start. What will happen? You will go here and run. Okay, so you can see my motor is running at 50%. Okay, it's running at okay. After that, you go to stop motor for 1. Okay, 2 seconds. Then after that, you will go and start motor again. Okay, now you start motor again. So run. You see, this one automatically will come out. You don't have to touch it because this is analog output. If here no number, something wrong with your scaling. Okay, scaling function. Because I assign 50, it will give me 16384. This is exactly 50. Okay, because 100 is 32767. Okay. So this one, after that, you can say, oh, okay. Then after that, how you simulate your overpressure? Okay, you don't go and double click here and say, oh, I want 300. And then you go and write. Okay, nothing will happen here. Okay, so you only can control your analog input. Where is your analog input? This is your analog input. Okay, this end pressure is your analog input. So I put 15,000 example. Okay, so once 15,000 turn on, it's over pressure, right? It will go to init. Okay. Okay, I have to stop the start button. Okay, so you will go back to init. Okay, start button also remember to when you press, right? You must release them. Okay, you press, you release. So now it's over pressure, right? It won't go and start the motor because now there's over pressure. Okay, so that's how you simulate input. Input, you click on the GVL analog in. Output, you don't need to care. Output, you just assign SP equal to what. Make sure here have some changes. Then your AI and AO are correct.